Hi guys, welcome back. So we have finished move our code to the ROS, and then next I want to make sure that we can get the stream from the camera streaming back to our laptop. So of course there is tools like RViz, RQT image view, but it feels like that those tools sometimes is not working well, in the sense like you need to set the QoS, and if your network is not good or Wi-Fi is not good or something, you couldn't get the stream at all. I have an experience like that, and I feel not comfortable to use those tools in ROS. So I'm going to use another tool which called the PySetMQ or PyCMQ. So it's a very good tool to stream the videos back to your computer. So if your computer using like a Linux, or in my case is Ubuntu, so you can just use the Python code to set up the stream easily and set up the viewer very easy. So I'm going to show you how to do that. So first you need to make sure that the JSON Nano have installed the wait a moment, we'll close this. So PySetMQ. So this you need to install this on both of your robot and also your computer. So I already have that, and on the code on the ROS Apple detection ROS.py, I'm going to import some new package, which is setmq and also base 64. So let me say it first that I couldn't remember that where I got this code, but if you try to search about like streaming by the setmq, then there should be some example code. So I just copy it from my previous code. Okay, so here first we need to set up the setmq streaming. So under here, I'm going to put setmq streaming, and then I'm going to specify port display. So it uses a socket. And then at the end, so basically we want to show in local, we're going to use imshow, but now we're going to use a network stream. We're going to use this one and code it. That's it. So we can just copy this to the JSON Nano, and then I can run it on, I can run the Apple detection ROS from SSH terminal. So we can just run it like this. So here I have the another viewer, which is always same all the time. It's never changed for the viewer side. So I'm going to show you the code of here. So it's very simple. You just import CV2 and setmq base 64 as same, and import numpy, socket, and struct. I think we may don't need struct. Yeah, we don't need struct, but we may need socket. Yep. Oh, we also don't need socket. Yeah, so I think we can even remove this. Okay, so if I run this on my computer, 3 setmq.viewer, if I forget to put the port, it's going to show some error. Then you need to run it again, like -- port with the robot IP. And the robot IP is 129 with the port of 5555. Then, bam, you're going to see that. So I suggest to turn on this viewer first. Okay, so we run this again. And then you can run this one more time. And then you will see that the stream is coming. So if I pointing to this, yep. So it's good enough. So we can see the view from the robot wirelessly. So that is good for debugging. So that is how we're going to stream the videos from the robot back to our laptop. So next I'm going to make the card control part. So we're going to grab the XC value and then try to control the card by making it move left or right. Okay. On our laptop again, we're going to make a new code which called cardcontrol.py. It's the ROS2 program. Then we need to define because we're going to send the command velocity to the robot, the JMOAB ROS2 AT card basic. So we need to have this twist. Then make the class of card control. We need to specify XC callback with the message. So if there is a message coming, we're going to store it inside the XC value. So we need to specify XC first. So because we are working with the CV frame, we better to set some threshold like in the middle, that if the XC value is like in the middle of the frame or a little bit like offset to the middle, we don't want it to make the car immediately turn. We just want to make it just keep going. But if it's out of the threshold a little bit, then it starts to steer. To do that, we need to specify something like this. So first, make a frame. So 40 on the left and also 40 on the right. So frame min dB is the middle of the frame minus 40. We also need to have the frame. So if the XC is between this frame max dB and frame min dB, it's just going to make the car go straight, no need to steer. Okay, we better to define the card parameter. Make a timer callback. So timer callback is as a while loop to control the robot. We need to grab the data from XC. If XC is equal to -1, we want to set the Vx, the linear velocity, as 0 and also angular velocity as 0. And let's put some drive state as some some text like stop, like 4 letters. So if the XC is between min and max dB, just go straight. If XC is less than self.frame min dB. So, but how much we're going to adjust the steering velocity? It's like I'm going to map, for example, if it's very close to the middle of the frame, so it should be just very small steering. But if the XC is very close to the edge of the frame, that means it should steer very hard to go to that route, right? So I'm going to use the map function. Here is a map width limit. We're going to use that map function. So self.mapWidthLimit. And next condition is if XC, if the frame max dB is less than XC, or XC is more than max dB. Lastly, if there is no, it doesn't match any condition, just put as 0, and just to avoid the error, we need to put some drive state like, how to say, what the fuck. So we have the fully defined if-else statement. Then lastly, we need to publish the command velocity. Okay, and then just to print out some of the state. Before we're going to publish the command velocity to the AT card basic, from my experience that we better to like smooth out the velocity. You can imagine that sometimes the point is just keep moving around, and we don't want the car to just immediately turn or like jerky. You want to make some kind of a smooth motion for the robot. So I'm going to make some kind of like a function that to smooth out velocity. So you can change this 0.9 and 0.1 to something that like 0.8 and 0.2. So it's like a complementary filters when you fuse the MU data. So lastly, we need to define the main. Yep, that's it for the card control. Okay, let's try to run this and see. Okay, we have card control here. Then here we're gonna run Apple detection ROS. And here we're gonna run card control. And on our laptop, I'm going to run setMQ viewer, setMQ, and Apple detection ROS. So let's see. Okay, here we are. So we have an apple, and then it's showing that if the apple is on the left side, we want the robot to go to the left. So you will see that the angular velocity is changing. And if there is no apple, then you will see that it was showing stop. Okay. The streaming here is quite slow because there is too many devices connecting in the network. But if there is just only 2 devices, my laptop and just a nano, it will be much faster. Okay, so we have finished the card control program. Then next, I'm going to put this just a nano back to the robot and also install the camera on the robot as well. And then we are going to try to run it when the apple is placing on the ground. And then let's see.